Hello. So, I am going to go through the process of getting a node set up such that it's able to connect to the voting app blockchain, as well as we'll probably go over like adding a key to MetaMask so that we can like make a transaction or something like that. You can also generate the keys with MetaMask. That's fine, but you need someone to send you some coins. And a big part of this is just going to be choosing the endpoints and stuff like that. If you do just want to get running as quickly as possible, then skip to the end, say 3 minutes from the end or something like that, and I'll go over just doing that as quickly as possible. Okay, so we can see my setup here. So I've got like GitHub just on the repository thing. We're mainly going here for the wiki for this page, and then a WSL instance just here. Yeah, and so we are going to go through and grab everything and get ourselves set up. So the first thing is we need to grab, so I tested version 3 of Open Ethereum. It seems like it works fine for our existing stuff, which is cool. So just go grab the latest release. Here we go. Oh, what type of thing is it? Oh, it's a zip. So, yep, so we just need to grab this. I did actually, for whatever reason, go and install Rust and stuff, I guess, because I was considering compiling it, but that's not super useful. So the next thing, actually we don't need that yet, but over here, so wherever the case may be that you've got a chain spec, so we need this JSON file. So the chain spec is, I mean, it's just this big JSON thing, but basically you can see like, you know, it's got a whole bunch of stuff, including, you know, like the authority around, details, a whole bunch of stuff about the initialization of the chain, as well, crucially, the boot nodes at the bottom. So then we just run Open Ethereum chain spec. If you do want to have RPC stuff, we'll definitely need it in this case because this is WSL2, which uses a more proper virtual machine, so it has a different IP and stuff. I'm just going off memory here. So what we're doing is we're setting this up so that we can accept RPC calls. To accept RPC calls, particularly because we want to be able to connect to it from MetaMask. So, whoop, oh gosh. Let's kill that. We don't want to... If we just start it normally like that, then we will join the mainline Ethereum network, which you don't want to do because it'll run hot and download a whole bunch of stuff. So, oh yeah. This is it going to be like bind or what was the thing? Interface. Cool. So, we have a look and grab our IP address here. Whoops. We should be able to. 8545 is the default port. Cool. So you can make a connection. Sweeto. Then we want to go over here, and I'm just going to allow MetaMask in incognito. And we've got MetaMask, so let's just open this one up. I'll have to find my password again. Where are we? So under the network here, we want to go custom, and then are we getting anything? Nope. Okay, we might need to log in first. So let's see. I have way too many. Okay, yep. Got a whole. There we go. So for the network here, we want to. I'll just grab this, and then I want to go custom RPC. Network name is like. Paste in the RPC URL, the chain ID and stuff, it'll try and get it, I imagine. So that should be fine. And then we go down here. From this, we can select whichever account that we want to use. So connecting, why is that not connecting? Alright, give me a tick. Oh wait. No, there we go. So I think, so I could see that we were bound to the right ports and stuff, but I just clicked localhost. It seems to have worked. So, is this gonna? Oh, it had a tick. All right, maybe not. I do know there's some WSL2 stuff that happens with port forwarding and things. So let me sort this out. Okay, so I did see. A thing in, we call it the dev console for, what do you call it? MetaMask. So there was like, oh, that was just a quote there. Well, here's like, you know, the double quotes. Anyway, maybe, if this doesn't work, I'm gonna have to figure out why. It does look like it is. Okay, the next thought is cause. So I think it's just what's up? I think that's what we want. Yep, there we go. That was it. Enable cause. Okay. So over here, we can have, you know, whatever account. As the case is, I am going to use one I prepared earlier, which shouldn't show up. Don't know what privacy mode is. I should probably find out though. Oh. Okay, there we go. As you can see, there is a considerable number of coins on this one. This is the, I think it's the, yeah, it's the publishing address. So this is what is automatically used at the beginning of the network instantiation to publish all the smart contracts. So let's create an account. There we go. And then, well, if we copy the address, so you can just use this exactly as you would a normal account. Oh yeah. Sweet. So we can see the transaction happening over there, which naturally we expect. But yeah, so we've like this transaction was published through like our node, but then through the network was signed in the same way that Coven or something like that would, Coven being one of the test nets for Ethereum. I guess, yeah, anyway, yeah, that's pretty much it. Okay, so now we have an address set up, we can use it. We've got our node that's running. Okay, so what I said before, if you do want to set this up as quickly as possible without going through like the process of running a node locally, even though you can see it's pretty simple, if we just go back to here, then in our list of attributes here, so this is the link for the chain spec, we've got, you know, a whole bunch of other stuff, but if we look at so the public node IP is definitely one place we can do it. we've got 2 nodes here. There should be is there a DNS name somewhere? Oh yeah, sorry, I should have just paid attention to that. No, that's the static one. There is, so a DNS name is created for the endpoints, but I'm not sure. Yeah, anyway, basically, come here, grab one of these IP addresses, then go over to MetaMask and add custom RPC. Oh, it might be SSL. Let's do that first and just see if that works. Oh, it won't work, of course, because, like, SSL protocol error. Interesting. Oh wait, no, this won't work because this is the node directly, which is rather what we like. The endpoints that will get published do have HTTPS. However, that's because they go through a load balancer. So that explains that. Let's ignore Flux remote, and then where is it? There we go. And this should work. Sweet. And then we can see, like, same thing, looks exactly the same. Yeah, that's basically it. If we try and send, just to demonstrate, so you'll see here that it looks different from this. Like, this says, you know, not preparing a block first, and then the thing, whereas if we do that, wow, okay. So whatever we've got on here, oh well, this is good to check. So the reason this showed up instantly is because of the settings that we have on the consensus nodes, like is in the validator/auditor type nodes, the authority nodes in this network, will try and sign blocks every 5 seconds, unless there's no transactions, in which case they won't sign any blocks at all. It's just to keep down, you know, space. We don't need extra stuff, right? So they will, but that means that if it's, like, if you send them a transaction and it's over, like 5 seconds since the last block, they'll instantly seal a block. So future timestamp in header. Maybe my time zone is, why would my time zone be wrong? Anyway, I'll fix that later, but that's how you get connected to the network, like, really quickly if you wanted to do that. Yeah, sweet.